Super excited to be here at GraphQL Summit. It's been a great conference so far, so many awesome talks and everything. And as Jesse just said, I'm here to talk about SDLs and Artifact, code-first schemas in TypeScript and JavaScript. Again, Tim Greiser, T. Greiser on Twitter and GitHub, and Director of Engineering at Cypress.io. And if you haven't heard of Cypress, we build tools to improve and simplify testing applications, specifically for integration or end-to-end style tests in the browser. And have heard from a lot of folks here that are using Cypress. And if you have not given it a shot already, I would recommend downloading it and trying it out. You might actually like writing tests with it. But I really love GraphQL, as do I think almost everyone here. I think as soon as it came out, I saw the potential for it to solve a ton of problems that I had faced in building really rich web applications with overfetching and things like that. And so to sort of start the talk off, I'm going to give like a brief timeline of my experience with GraphQL and sort of how it has shaped my opinion and what I'm going to be talking about for the rest of the talk. So in 2015, GraphQL.js comes out, and immediately wanted to start using it in production, and happened to be working on a project that was kind of greenfield. And so I pulled this from the code base. This was one of the first GraphQL types that I'd ever written. And it's a GraphQL object type written with GraphQL.js. You can see, it has the string fields for different things that pertain to a location, and you've got your lat long, and it was like a mobile ordering type app, so it's got like the cuisine. And then, when that's built as a schema, it's emitted as this artifact, this type. So it's like the location it implements node for the relay style connection, and it's great. It's a little verbose on the left, but it gives a lot of benefits. And so from there, a little later in 2015, there was this library that I came across called graph.ql. And I think that this is, as far as I could tell, like the first time I had seen SDL first approach to building schemas. And so what this allowed you to do is take your SDL and then wrap it with this function and then wire up the resolvers that you need for only the specific fields that you want to add things for. And this just seemed much simpler to me than having to import all of these types and sort of wire them up in this object literal. So it was much more concise. And so if you compare the two, you can just see the lines of code are significantly less on the left there. And so that sort of has become what we're used to today. So Apollo built really great tooling around that with GraphQL tools, and it's super great to get started with. Like you just write the SDL schema, which is pretty concise, and everyone reads it because it's common to all. It's the GraphQL sort of standard, and then you have a schema up and running, your GraphQL application. So then later in 2017, I started a company that was predominantly a Python shop. And when I got there, I noticed that they had a ton of problems that GraphQL sort of sets out to solve with overfetching and all of these various endpoints that were specific to individual use cases. And so I was trying to pitch, as a new person at the company, pitch that we should be using GraphQL, this new technology. But there was no way I was going to convince an entire shop of Python developers to switch their programming language just to use this new technology that they were already sort of skeptical of. So I went and took a look, and the library that's most popular in Python is called Graphene. And so I took a look at the example, and I was like, oh, it's not SDL first. It's using the code first approach. Like, is this going to be a problem? I really liked the way I was doing it in JavaScript. But then, worked on it a few months and sort of built the schema out, got buy-in from everyone, and realized that I really liked this approach of building the schema programmatically. Like it scaled really well to multiple teams working on the same schema. We just sort of set conventions for how you were able to expose sort of the different pieces of the app that you wanted to be in GraphQL from the back end, and it worked really well with the existing development flow. And so some stats, just to give you an idea of like the size, it was like a couple hundred types, a couple thousand fields. We had some deprecations. There were no custom directives in the schema, and that's actually also sort of part of the SDL first approach is directives are to annotate and augment the behavior is kind of specific to JavaScript. There were like 4 different teams, 18-ish developers, I think, working on the same code base, and it worked really well. It was successful. And just for comparison, like GitHub's public API has a couple hundred types, a couple thousand fields, so it wasn't a massive application, but it was decent size. And so then in 2018, I was working on a project that was GraphQL Ruby, and again saw that GraphQL Ruby uses classes and generates things programmatically. You're using the objects that you're used to in the programming language. You're not writing SDL and then connecting things to that. But then in 2018, I was like, I really miss JavaScript, TypeScript. I was getting into GraphQL tools and GraphQL Code Generator. And by the way, if you haven't tried GraphQL Code Generator, we use it a lot at Cypress for front-end types and for custom types for testing, and it allows you to really easily programmatically build up these TypeScript or Flow or any type definitions that you're looking for. So it's a pretty cool project. But I was still in the back of my mind like thinking that there was something missing, and it sort of clicked for me when I was at a GraphQL meetup in New York City, and Mark from GitHub was giving a talk, and somebody asked a question afterward like, how do you do SDL like this or that? And his answer was sort of like, I don't really know, because that seems specific to the JavaScript community. And it sort of felt like the JavaScript ecosystem might be missing out on something. And then I came across this in the GraphQL JS GitHub issues. I came across this post by Lee, one of the creators of GraphQL, where he mentioned that the SDL was not originally intended to be a human-written document. There's plenty of design decisions that favor readability over writability. So if the creators are like, we didn't intend for it to be used this way, like maybe that's another reason that we're missing out on something here. So maybe we're doing it wrong. And so what this talk is going into is like, what might a better code-first approach look like? Specifically with a library I've been working on for about a year called GraphQL Nexus, which aims to be an improved experience for building code-first schemas in JavaScript and TypeScript. So first, I'm just going to touch on why not SDL first, and then talk a little bit about GraphQL Nexus and what it does around this. Some related tooling in the ecosystem for code-first development in JavaScript, and then how like SDL is still like an incredibly important thing for us to know and communicate with. So why not SDL first? One of the big points for me is code duplication. So if you think about, you have like an enum type, and presumably there's something in your runtime language that corresponds pretty much one-to-one to that. Like here, I'm just giving an array of these types, but you might have an object or something like that. And any time that you need to modify one, you have to go change the other. And so it's sort of like this double declaration problem, as I'll put it. And same thing with interfaces, right? So if you use interfaces, any field on the interface also has to exist on the object type that implements it. So here in GitHub's public API, they have this uniform resource locatable interface, which has these 2 fields on it, and there's 16 different objects that are implementing that interface. And so if you wanted to add one more thing to that interface, you then have to go find all 16 places in the SDL that you've declared it in your code base and make updates there. And so I think sometimes, and same with documentation, like when you're writing the doc strings out in the SDL, you sort of sometimes just won't do it. Whereas if you have it in the programming language, it's easier to sort of build abstractions that enforce good patterns for these things. So I think sometimes you'll end up taking shortcuts by programming with the SDL. So there's also, along those lines, the documentation and type ordering. So GraphQL JS has this lexicographic sort schema, which when you generate the schema, you can pass it in there and it sort of sorts all the types correctly. And then when you call the print schema from GraphQL JS, it makes sure that the schema prints the same way every single time. So when you're making changes to the schema, the diffs are really clean, and you don't have to worry about like where things are ordered in your code. It just kind of prints really well if it's checked into the code base. So you don't have to worry about that, and that's much harder to sort of set standards around and maintain when you're handwriting it. Again, and building for larger teams. So if you're working on the same code base, I think that what I found, at least with my experience with Graphene, was that we had some teams that looked like this. So we had 4 different teams: search, budget, and expenses, whatever. And so they had their domain of the application, but it was all in the same code base. And then we were able to say, okay, well, here's how you just kind of wrap the different objects in certain ways, and as long as it's imported into this manifest that gets all the GraphQL types from all over the place, then it just becomes part of the schema really easily, and didn't have to worry about breaking all of these things up into different services just to get it to work. So it ended up being a really nice experience, and you could see how changes to code immediately impacted the schema. I think there's a lot of tooling that is built to solve the problem of like GraphQL modules or different things that are all pretty good and pretty impressive. But I think that we're sort of building tooling that is intended to fix a problem that maybe shouldn't even be a problem in the first place. And so microservices is the last point. So if you're a very large organization and you're already using microservices, then it makes sense. But I don't think as a starting point that you want to think of microservices as a solution to solve how do I build a large schema with GraphQL. So now I'm going to talk about GraphQL Nexus and how it tries to do some things to help with building your schema in a code-first approach. So you can check out the documentation, nexus.js.org, and read more about it. But what is GraphQL Nexus? So it's a code-first library, obviously. That's the title of the talk and what I've been talking about so far. It's declarative. And what I mean by that is that if you have a GraphQL type that looks like this in the SDL, then the object type used to generate that, it maps pretty similarly. You're not just kind of auto-genning this code that's you don't really know what it looks like or whatever. You're still being intentional about the schema. You're still building it schema first from how you're thinking about the types, but it's just that you're doing it with a programming language where you can build abstractions and build sort of higher level things that I'll go into. It's also aims to be type safe, and type safe with TypeScript specifically, and I'll go a little bit more into how it does that, but also JavaScript friendly. So it doesn't try to use too many advanced features of TypeScript in a way that makes it so that you can't use it with JavaScript. If you want to use it with JavaScript, that's great, and you actually can get autocomplete in IDEs that can pick up type completion, IntelliSense, those things, based on how the library it works. It's also extensible. We have a pretty rich plugin layer that is just shipping now, and we're pretty excited about that. So the first question that I ask when I encounter like a new piece of technology is what makes it different? Why do I want to check out this tool versus anything else? And for me, it is the development feedback loop, the way that you work with Nexus. And so the way it works is you call this make schema function, and you give it the types in your code base that you want to have be part of your schema. And then from that, it sort of wires them all up, and I can go into that in a second, and it outputs the SDL as an artifact, so you get like a .graphql file, which is great for when you're sort of seeing how code changes affect the actual contract that you have with your consumers, with your clients, web, mobile. It also outputs some TypeScript types in a way that we're able to sort of infer and know what sort of the source type of a resolver is or what the return type of resolver is without you having to annotate that type in TypeScript. And then it just creates a regular GraphQL schema that you can feed to Apollo server or whatever GraphQL sort of server that you're using. So then those generated types are inferred by TypeScript, which gives you that nice developer experience that I'll demo. And then as you make changes to the code, if you're using something like NodeMon or TS Node Dev or something that watches the files, and when you make updates, it restarts the node server, it just kind of goes back through this loop. So it restarts and then regenerates. And so as you're editing, you're sort of changing the types, and it just kind of automatically happens on the fly. And so to give an example of what this looks like, we'll go ahead and start a server. And this is in the code base. We have some examples. This is the Star Wars API example. And you can see we have an object type and some enum types. And then we've got the droid type. And we've got a query type here. And we'll go ahead and add a new field. So add a string field called test. and we'll go ahead and return 1, and that gives us a TypeScript error because it's supposed to be a string. So we'll go ahead and change that. And then we'll add another field, and we'll call it droid. And we will make some typos. And then, so as you can see right here, there's a drop-down of all the different types. So you can either import the type, or you can just, because of the types that we generate, refer to it by its string. So here we're resolving the getDroid function, which takes an argument. So we'll go ahead and add an args on the definition, say id string arg. And now if we do root args, we'll see that we have ID string there. So that's automatically inferred, no typing there. And then as we take that away, we see that it goes away. And so we'll do args.id. And we'll see there's still an error. And so it's because undefined is not assignable to string. So let's go ahead and look at the schema. And you can see here that it's a string ID, but not a string exclamation point. It's not required. So we'll go back and we'll add required true to that, and then it type checks. And then we can see sort of these are some of the types that it's generating behind the scenes in order to infer these things correctly for you. And it's doing all of this as you're sort of coding. And so, yeah, type safety is a big point of this library. Although, like I said, you don't have to go into that if that's not what you're interested in. So the way that it works is you specify the outputs. You specify where you want the schema to be emitted and where you want this type sort of completion helper file to be emitted. And then you give it some hints about what the source types of the resolvers are. So by default, if it sees a type with a name like droid, if it finds in that backing types file an interface or a class or something type named droid, it will automatically know how to associate it. And you can configure that. And same with the context. So the third argument, if you have an object that uses that. And so then this is generated in development as you're iterating. And like I said, it generates a normal schema. And so how does this work? You can dive into the code. It's kind of tricky, but it uses an advanced feature in TypeScript called conditional types, where we're able to sort of capture the name of the type and the name of the field, and then sort of infer it based on looking it up in the types that we're generating. But you don't have to know anything about that. But the end result is type safety with less typing. That's the goal, at least. And so we have a pretty rich extensibility and plugins layer that allow you to build custom type-safe abstractions. So one example is authorization. So you want to control who is able to see certain fields, especially at the top-level queries. You want to make sure that the person has access to or mutation, anything like that. So this authorize is implemented as a field authorize plugin. And the way this works is that in the library, by default, if you go to add an authorize field, you'll see it doesn't exist. And we'll go back into the schema, or we'll see here, there's nothing in the plugin sort of types. So we'll import this field authorize plugin, and then this will add the typing for the authorize, sort of modifies the contract of this of the API signature dynamically. So these plugins are able to sort of modify how the platform works specific to how you want GraphQL to work in your application. So you see if we delete the plugin, authorize is no longer there. And so you can imagine that this can be used to build up sort of really powerful things that are specific to how you want to use GraphQL. One thing that we run into, let me make sure that this, one problem that we have had with GraphQL in production is that sometimes a null slips through, where if you have a non-nullable field, a null is coming from a third-party API or a database, and it somehow breaks the contract, and you get the dreaded cannot return null for non-nullable field. And so in Nexus, we have this plugin that is called the Nullability Guard plugin, which essentially tries to guard against these non-nulls from slipping through by providing a sensible default. So if there's a string field that returns null by accident, then it will guard it and return an empty string instead. And so what it does is it looks at your schema after it's built and asks you to give default values for each of the different scalar types that are seen in your schema. So in this schema, we are using string, ID, and Boolean. So we'll give empty string, missing ID, and true. And then we can go ahead and try it again. And still broken, but that's because it only runs in production by default. So like if node env is production, it will guard. Otherwise, you want to catch these things in development. You don't want to use this as a crutch. So you can see there, it went through, and it logged out that the nullability guard was called for this field. And so we can provide this onguarded that says like when there's a guard, you could imagine you'd want to log an error, for instance, to your error service. So what this allows, I guess, is ways that you can build modifications to the way that GraphQL is working in your system in a way that's type safe and sort of works very well across the entire schema. So an example of what a plugin looks like, this is just a very simple example, is we want to log how long a mutation takes. So we say like, on create field resolver, we'll say if the parent type is not a mutation, then don't worry about it. Otherwise, we'll return almost like this middleware style function that is a resolve with like a next at the end. And so we can log the start time at the beginning and then call the function, which is the next thing in the plugin chain or the resolver. So in this case, it would be the mutation. Get the value and then call end time after that and then log it out as for how long that mutation took. We also have on missing type, which is like if you want to dynamically create types based on like as you're generating the schema, if you have sort of some boilerplate, like at Cypress, we have this resource response type that we sometimes want to return this object where it has OK if we don't care about any fields there, the resource that was modified, and query if you want to query for more data from the root type. And so if we just provide that string project resource response, it will automatically sort of guard against that in the on missing type and create that type on the fly for us. So there's some pretty powerful things that we can do in here. There's also ways that you can build dynamic types to modify that T object, so to add fields. So here we have a T.connection field. And again, it's type safe in the sense that we defined a contract for it, so we can see that like nodes is missing. And so you can essentially like find common patterns and abstract them away in a way that works, I think, pretty well for building larger schemas. And so yeah, the takeaway is that it's trying to make something that was previously pretty complicated to do with SDL a lot simpler with a lot more sort of options for you to go about doing it. Prisma has been using this pretty extensively with their Nexus Prisma plugin, which aims to sort of simplify a lot of the boilerplate of creating a database application. So they have this CRUD dynamic property that they're adding that sort of, based on what they know about the database schema, they are able to wire up all of these defaults for you so you don't have to generate all of these fields. And then if you want to modify things, you can go in and do that just as easily. So yeah, the idea again is augmenting library behavior, both runtime and types, which I think is kind of unique based on the user-defined constructs. We have an SDL converter. If you're curious, you can paste your SDL on the left and see what it outputs as Nexus types on the right. There are still some rough edges to this. It's still like a very early project. Like there's a lot of experimental things. So there's some configuration that you need to do up front. Because the types are dynamic, the jump to code doesn't always sort of work the way that you'd expect maybe. TypeScript errors can be kind of cryptic sometimes, but I know that they're getting a lot better with that. And then there's also sort of the chicken and egg problem where because the types don't exist to begin with, it's not type safe, I guess, until you run it the first time. So you sort of have to run it with like ignore all of the type errors the first time, and then it's fine. But overall, it seemed to work pretty well. We're using it in production at Cypress, and it's been great sort of getting everyone on board and developing the same way. And it's been really consistent to sort of build and add new features. There's a lot of other code-first tooling in the JavaScript ecosystem, though. There is TypeGraphQL, which is more of a traditional approach to TypeScript, where they're using the field-level decorators. It doesn't work with JavaScript, but it's a pretty cool solution if you're interested in that. There's also GraphQL Compose, which I think of it as like if you took the inside of Nexus and sort of inverted it, like flipped it inside out, that it has a lot more sort of imperative helpers that allow you to build up these types programmatically. And I know Gatsby uses this under the hood for sort of the way that they do things that are more unique in their tooling. But I think that SEL is still really useful, right? Like it's the common language that we use to communicate between all these things. And it's also really great for getting up and running very quickly with a GraphQL server if you're using the GraphQL tooling. But at the end of the day, like users don't see our code, they just want like a good experience on the web. So I would say just pick whichever tools help solve your problem. I don't think one is necessarily better than the other. It's just kind of showing that there's different options out there. So thank you for listening, and thanks.
Absolutely, a big round of applause for Tim. Thanks so much, Tim.